right, we're going to work a little bit more with polynomial equations today. A lot of it is stuff you already know, but just kind of doing it in different ways. There are a lot of different types of questions that can be asked with polynomials. So I want to focus on this little graphic right here, in that no matter where you start, they are always related with these three things. So we can have an intercept, which would be a point. So they give you x comma 0. Okay. If you have an intercept, you can get a factor, okay, which would be x minus the root. If you have a factor, you would know the root, which is just the x value, which also relates to the intercept. So these all really relate together. Now let's do one with a number so that we kind of have a better idea here. So let's say we are given that a root is x equals 5. Well, what's the x-intercept then? 5 comma 0. What's the factor? X minus 5, because it's opposite. These all relate. So it just depends on what you are given first in a problem. Maybe they give you a graph, and so on the graph you see that you have this intercept. Okay, well, from the intercept you could write a factor. So that could be an option. Maybe they give you an equation, and so the equation has factors in it. Well, what are you going to do with that? You're going to graph the intercepts on your graph, which we've done. Okay, or maybe they give you a root and they ask you to write an equation, so you get the factor. Okay, no matter where you start here, you can go here, or you can go here. If you start here, you could go to that one, you can go to that one. These all relate. They all have that 5 in it. They all mean the same thing, but they're just in a different way. So let's see what we can do with this. We want to write a reasonable equation of a polynomial function of least degree in standard form. So there's a lot of words in there. Let's talk about what each one means. Okay, reasonable means we don't have to find the a value. Now, before we left on our break, we did figure out, that looks like it says Noah, hold on. No a. We did figure out how to find the a value. So we've done those together before. Reasonable means we do not have to do that. Okay, let's look at the next polynomial function, least degree. That means don't add things. Now this one is kind of a duh situation, because why would you make an equation more complicated than it needs to be? If I give you roots, those are all the roots you can use. Do not add your own. I don't think you would anyway, but that's what least degree means. And then our last one here, standard form, this is the bummer. Okay, standard form does mean that we have to take our factors and multiply them out. That's going to be the most annoying part for us. All right, so let's get started here. So we are writing a reasonable equation. So f of x equals, okay, I'm not going to put an a value because this is a reasonable equation. I have a root at 7. Well, that means I have a factor of x minus 7. And I have a root of negative 4, which means I have a factor of x plus 4. Now, I could do other things. I could add in an a value and it would still be reasonable. I could make the root at 7 squared, even though it didn't say that. Okay, but because it says least degree, I'm not going to do that. I'm not going to add anything that's unnecessary. Okay, so we've got the reasonable part. We're not finding a. We've done the least degree, but unfortunately now the standard form is going to happen. So standard form means that I do need to multiply this out. So I'm going to make a generic rectangle, x minus 7 on one side, x plus 4 on the other. X squared, negative 7x, 4x, and negative 28. Okay, so my final answer, f of x equals x squared. We've got a 4x and a negative 7x, so that's negative 3x minus 28. Okay, that is a polynomial equation. It is least degree, degree of 2, and it's in standard form. Okay, let's try this one. All right, f of x equals, no a value here. I have an intercept at 7. Now I'm going to go back to the last one. The last one gave me roots. This one is giving me intercepts. It doesn't matter. We're going to do the same thing with them because of this graphic here. We can be given a root and we get a factor. We can be given an intercept and we get a factor. They have the same relationship anyway. So when we had the 7 here, that gave us a -7. When we have a 7 here, that's going to give us a -7. So we've got x minus 7. Now I've got a root at 3. So x minus 3. And I have a root at -1. So x plus 1. Okay. Now the crummy part, we do have to get it into standard form. So I'm going to start with these two here. We've got x minus 7 and x minus 3. Okay, x squared, -7x, -3x, and positive 21. So I've got x squared minus 10x plus 21. Now, unfortunately, that represents these, but I still need to multiply that by x plus 1. So I'm also going to use a generic rectangle there. Now, this is a little bit of a different shape because I have 3 parts here with my x squared minus 10x plus 21. And then I only have 2 parts for my other one, so x plus 1. X squared times x is x to the third. We get -10x squared, 21x, 1x squared, -10x, and 21. Okay, I'm about ready to write my final answer. So I've got f of x equals x to the third. I'm going to stop there for a minute. If we look up here, we had 3 roots. I knew immediately when we have 3 roots, that means that I am going to get an x to the third in my answer. Okay, that has to match based on our last notes. You have to have the same number of roots as the degree of the polynomial. All right, now I'm going to look at my x squared terms. I have an x squared and a -10x squared, so that's -9x squared. And I've got a -10x and a 21x. That gives me plus 11x. And then the last one, plus 21. Okay. Move on to my next one here now. Write the exact equation of a polynomial of least degree with the following information. Okay, so let's make sure we know what all of these words means. Let's see, exact. What is exact going to be for us? Exact means, yes, we got to do the A this time. Okay, least degree. Don't add anything. Don't get fancy. But what is nice about this one, it does not say in standard form. So that means we are allowed to leave it in factored form, which, yay, I'm happy, I'm smiling, I'm clapping, because that is a lot less work. We saw on these last examples, this was a lot of work here with all of these generic rectangles and a lot of room to make errors. So we really prefer not to have to do that. So I think it's easier to find the A value than it is to have to do the standard form, but I think that's a personal preference as well. All right, so I'm going to get started here. We've got f of x equals A. Okay, as soon as I see that exact equation, I've got to have A in. I've got an x-intercept at 1. That means I have a factor of x minus 1. I have an x-intercept of 3. That means I have a factor of x minus 3. And then I get to this one that is not an x-intercept. And so then I know that is my point that I'm going to use in order to find the A value. So my x value is 2. My y value is -3. So -3 equals, remember f of x is like y. A I don't know. X I do. 2 minus 1 is 1. 2 minus 3 is -1. 1 times -1 is -1. So that means I have -1a on that side. Okay, I divide by -1 because I need to solve for a. A equals 3. And then make sure that you write your final equation. f of x equals 3, x minus 1, x minus 3. And that's it. We do not have to make a generic rectangle for these. Yay, that's a lot easier. Okay, let's do one final example. Same thing, we are writing same directions from this previous one, so we're writing an exact equation, least degree. So exact means we do have to find a, least degree, we're not getting fancy and adding anything, and it did not say in standard form, that means we do get to leave it in factored form. So f of x equals a. That's my start. Now I'm going to go to my graph, and I want to find my intercepts. I have an intercept here that is at -3, so that means I have x plus 3 in my equation. It goes straight through there, it doesn't do anything fancy, and so I have a 1 as my power there. I don't need to actually write that, but I just want to make sure you guys see that we did have to look at the graph to decide on that. So I did choose a 1. Okay, and then I go on and I look for my next intercept, which we've got one right there. That's at 2. So I'm going to have x minus 2 opposite. And I see there that it is a bounce, so that means I have to have a squared on that. There are no other intercepts, so I cannot add any other factors. So now I need to find my a value. Now in this previous example, once I got here with my roots, my intercepts, I used my special extra point, which they gave me. It is not given here, like written out, but we can get it from the graph. You'll either see a place where you can see that it crosses nicely, or sometimes they only put a dot, or on this one really nicely, not only did they put a dot there, but they also even labeled it. So that makes it a little bit easier for us. It's very clear that's the point we're supposed to use. I need to use a different color. Okay, 0, -6. So -6 equals a, 0 plus 3, 0 minus 2. Don't forget that's squared. It makes a big difference. 0 plus 3 is 3. 0 minus 2 is -2, but -2 squared is +4. So over here we get 3 times 4, which is 12. So we have 12a. Okay, divide by 12. A equals -6 over 12 is -1/2. Okay, and my final answer, we've got f of x equals -1/2 x plus 3 x minus 2 squared. Okay, so just a couple things I want to make sure we really got from this. Again, is that relationship, no matter where we're starting, we have this relationship here between our 3 pieces of information. You are given all of these. I will give you graphs, I will give you intercepts, I'll give you roots, I'll give you equations, and somehow I'm going to ask you to do one of the other ones with it. But as long as we know the relationship between the two, we can always make that connection. There's a big connection between that equation, graph, and then just the roots. So we'll be practicing with that. Your worksheet will practice all of these different types. And please let me know if you have any questions, either by email or let me know, and we'll set up a chat at any time.